Good evening, students. I trust that you are well. Trust that you gave us a good one for you.
Good evening, sir.
Yes. And I also believe in heaven. And I trust that you are you're in a frame of mind ready to work. Um, had an opportunity to just really relax and just get a little lazy today. And in reflecting on, and in particular the last hour before the start of the class, just reflecting on your progress and just looking at what it is that I have to complete that. I thought to myself, it may best suit the class if I were to go through just one more question on stationary point. But this question I'm not going to do in half of an hour or 45 minutes, those things. I'm going to ask you to take 15 minutes at most to see if you can get this question out of the way. Generated an equation, and all I did was just copy the 1, 2, 3, 4, 5. I was trying to put as many of those in there so that at least you can get the levels of practice that I was expecting to get. Those of you who are struggling with the topic, I am going to ask that you try as best as possible, even if you have to look up in your book. I have no problem with that. But I want you to try and complete the question on your own. For those of you who are understanding, what is important for me is for you to try as best as possible to do the question without looking back. I am not there with you. I want you to be honest with yourselves. Try and be honest enough to just do the question on your own. Where you get stuck, then you can go back. But at the point that you get stuck, I want you to make a note here. So that when I'm going through the stuff with you, you can say to me, sir, this is where. So at least I can see if I can give you any tips as to how to go about. Remember, you're doing face-to-face exams, and you, of course, can't take your books inside of face-to-face exams. So I really want to be able to be of some help for you. So I'm going to ask you, please, starting now, just go through the question. I have not done the question. I only generated the function just now. I'm going to give 15 minutes. I don't want to start working on it yet because I want to be able to for you to see what it is that I'm doing when I'm doing it. All right. So, on the mark, get set, go. Any questions I should ask first? Are there any questions of me?
Yes, sir. I just came in the meeting, so good evening, by the way. What are you covering?
All right, then no problem, Papa. No, I wasn't calling. I was just giving a little bit of classwork just to see how good you guys are at doing this stuff. So just go ahead and do it for me. I hope you see my screen. Are you all seeing my screen?
Yes, sir.
No, good job. Thank you. Are you all okay? Does everyone understand what is required of you tonight?
So far,
Well,
I told you about it.
Students, are you seeing a screen?
They don't know how to be.
Yes, sir.
Oh, okay.
They're children.
It's just that I log into another device and
I
I'm
saw
not
that
seeing
they
the
were
screen.
lazy
Continue
and
working.
needed to go back to basics. That are manifested by their behavior. and to reframe teachers' role in the classroom.
Yes,
Training
no?
should help
No,
teachers
sir.
to recognize the source of
Sir,
harsh
no, I'm
behavioral
not.
management strategies and help
Okay,
them
but
to
I think I
change
did
their
something.
mindset. And so the role of the teacher,
Don't think
especially
my
at the early
expression is
childhood level, is more to train
factionable
children
any
in how
rational
to
number.
manage their challenges
Stuff.
while establishing
Alright,
healthy
the aim is
boundaries
not for me to rush
to
you, because I want you to be able to
behavioral
complete this
management
one
strategies,
question on
such
your
as
own. So let me give you 5
taking
more
away
minutes.
privilege.
Go back to him
Okay.
after and try and see what you can figure it out here.
Teachers need to see their role as
Sir?
so all the best as you go forward.
Sir? There's a black thing over the function. Can you remove it, please?
navigated us through
Students, you are
the
awfully
event
quiet.
and charted
Somebody
our
clear your
course.
throat now, so I know that you are there.
We say thank you to those who brought
I
various
want to know that you are
greetings
still working.
and
Are you
remarks
okay?
at the event,
Should I start
including
now?
Professor Dale
Yes,
Weber,
thank you for clearing your throat. Let's
Pro
see, I
Vice
hear you.
Chancellor
Sir, you can start now because I'm
of
stuck.
UWI Mona
Where are you
Campus,
stuck?
Professor Sylvia
What part?
Cohenberg, the Dean of the Faculty of Humanities and Education, Dr. Marcia Rainford, Director
Joe?
of the School of Education,
Sir?
Mrs.
ask the
Michelle
question.
Campbell,
Sir, what was the
Director,
question?
Cross-Sectoral
What section
Coordination,
are you stuck in the
Early
question?
Childhood Commission.
Sir, the second one, the
We thank
critical
Ms.
points.
Carol Palmer, who opened us in prayer, underscoring the preeminence of God in Professor Cook's life and in all her pursuits, professional and personal. Additionally, Ms. Palmer's physical presence, along with that of her husband and her son, the other one joined virtually, reminds us of family, and that is other important force in Professor Cook's life. Earlier, we thanked Dr. Levine, and we wish to thank all colleagues from the School of Education, past and present, who have worked with Professor Cook, who have journeyed with her and supported her along the way. Appreciation goes to Dr. Carter for introducing Professor Cook to this team in a wholesome way and giving us immense insight into her academic career and that career trajectory.
All right, I'm just being
Mrs. Brown and Dr.
okay.
Mrs. Leo and Dr. Brown, their performances left us feeling wowed and added.
I'm just trying to be efficient instead of having to retype all of this. I'll just type over it. So I'm just
All those who provided written, logistical, and technical support for this event. This includes Mrs. Sophia Jones Johnson and other administrative and support staff.
all right. So here it goes. You're asking for the stationary points for. Oh, come on. All right. Be a nice computer to do this. All right. So when I differentiate x cubed plus 6x squared plus 9x plus 4, what do I get?
0 for me.
Hmm? When I differentiate x cubed plus 6x squared plus 9x plus 4, what do I get?
Sir, 3x squared plus 12x plus 9.
3x squared plus 12x plus 9.
Excellent.
Plus 9x and I then
No, plus
change it to
9.
9.
Oh, 9.
Right, to 9, 9.
I then change mine to 9. I have a next line.
Right,
And I
okay.
change it to 9.
Okay, so my differential is going to be 3x squared plus 12x plus 9. So for stationary points, I'm going to set the derivative equals to 0. I'm
Yes,
setting the
sir.
derivative equals to 0. So it's going to be 3x squared plus 12x. Remember,
X
I
plus
am
9 equals 0.
right. Remember, I'm typing over some stuff to make it life a little easier for me, and I can go through very quickly. What am I going to divide through by?
Sir, 3.
Good. And I'm going to get what?
Sir, x squared plus 4x plus 3
4x
equals 0.
Equals 0.
So look at what I have. So this is why I do what I do. It makes life so much easier for me to go quickly when I do this. So I'm now going to be factorizing I'm going to be factorizing that. What are the factors?
1 and 3.
Sir, 1 and 3.
Excellent. brackets are 1 and 3. Excellent. So I'm gonna have look at that. X squared plus 3x plus x plus 3 equals 0. Do you agree with that?
Yes, sir.
Let me check my
Mhm.
x squared plus.
Sir,
4x.
Yes, sir.
Remember one.
the factoring part, sir.
Mhm.
Can you just explain that part for me, please?
So I'm multiplying the
So I may
coefficient
have
of
one
x.
x, but you know in a
Same
meaning.
difference. Same difference.
Sir?
I'm coming. I was just answering Lottie. Forgive me. I'm coming to you, son. Same difference, Lottie. Don't worry about it. If it makes it better for you, see, I'm putting it in blue. All right. So do you have this? Do you have that section, son?
Yes, sir, I do.
All right, cool. So what I'm gonna do is to multiply the coefficient of x squared by the constant. The coefficient of x squared is 1. 1 times 3 is 3. I need two numbers. When multiplied together will give me 3, but when added will give me 4. What two numbers can we think of?
1 and 3.
Absolutely. There are only two numbers in the world that can satisfy those two conditions. All right. Now, I'm going to change my factor 4 into 1 and 3. So that's why I'm breaking up this 4x right here. Let me spotlight. No, I don't like to spot that because I'm typing. It's going to give me problems. But just work with me. This 4x, I'm breaking up this 4x into 3x plus 1x. Can you see that?
Yes, sir, I can see it.
Okay. Well, you agree with it too, right?
Yes, sir.
All right, good. Now it is that I have 4 terms I can go ahead and group. So in grouping, I'm going to put the first 2 in one bracket. So I'm going to put x squared plus 3x in one bracket. I'm going to leave out the middle sign, and then I'm going to put x plus 3 in the other bracket. Remember, when there's a plus sign in betwixt, you don't have to do any flipping of any signs. The only flipping of signs take place when you have a negative sign inside. So watch me. What is common between x squared and positive 3x? Say x.
Sir, X.
X, sir.
X.
And what is left?
X, sir, X plus 3.
X plus 3. Very good. What is common between? What is common? What? Right. Good. What is common between x and 3?
Should be
1.
Sir,
1.
nothing?
1, sir.
1. Don't say nothing. 1. Good. So it's going to be 1, and then I'm going to write out my x plus 3. Now my question to you is, what is common here that is common there?
X plus 3.
Very good. And what is left?
X plus 1.
Excellent. Excellent. So x plus 3 times x plus 1. So one of two things. Either x plus 3 is equal to 0, and that implies x is going to be equal to negative 3.
Negative 3 and negative.
Good. Or x plus 1 equals 0, which implies x equals negative 1. Talk truth.
Yes, sir.
And those are what I have. So my stationary values are x equals negative 1 and x equals negative 3.
Negative 3.
I'm pausing there.
That's a critical values.
Oh, it's a critical values? The question said critical values? Okay, critical points. So let me put, instead of put stationary values, let me put critical values. Same difference, but let me just be consistent. No man, the question up there said critical points.
Critical value. Oh, yes.
Oh, but another ask first. Well,
You ask
ask
for
first
the
was
y-intercept first.
yeah, let me go. Let me pay attention. Sorry, forgive me. Right,
So I try to write the critical points first and then.
let me just and it's for me always get myself into trouble now. I am midstream of trying to type something, I leave it blank, and then now, right, you see. C-R-I-T-I-C-A, and then I end up not remembering what I was doing. All right, so those are my critical values. So I get my critical values as x equals -1 and x equals -3. Are there any questions to that?
No, sir.
Yes, sir.
Go ahead.
The -3 and the -1, sir. How did you come by that?
Can somebody respond, please?
Have to equate the factors to 0, and then when you bring the values across the equation sign, you're going to get -3 and -1.
And that's the first time she's speaking in my class, so I'm going to congratulate her. Thank you, Miss Kate, for responding. She claims she's shy, but anyhow, very good. Yes. So so what happened is either x plus 3 is going to be equal to 0. Okay, so look at this x plus 3 times x plus 1. If x plus 3 times x plus 1 is equal to 0, it means that either one or both will be equal to 0. Talk truth. Somebody talk to me, please.
Yes, sir. Yes, sir.
So if x plus 3 times x plus 1 is equal to 0, it takes just one to be equal to 0, or both of them can be equal to 0. So if x plus 3 is equal to 0, I'm using the additive inverse to say, what do I add to x plus 3 in order to give me 0? And that response is going to be -3. So the additive inverse of 3 is -3, and the additive inverse of +1 is -1. So that's what we use. Are your questions answered? Talk to me.
Sir, I get what I was looking for, sir, because I had +3 instead of -3, so I got the answer.
Okay. Mikey, was that you a while ago? Asking the question?
Well, that's the
Sound like
question, sir.
Reggie. Not
Oh.
sure.
Rajay, was it you?
No, it wasn't me, sir.
Who did ask the question? Somebody just respond, please. The asker of the questioner. Can you just let me know if you're understanding, please, so I can move on?
So what was the question?
You remember.
Which question, sir?
The question was how I get the -3 and the -1.
Yes, sir. It was me. It was me, sir.
Hey, Mikey, you're gonna buy lunch for everybody in the class tomorrow, you know? And I'm sure I know your voice. All right. Yeah,
Yes,
but
sir.
yeah. Are you seeing that now, Mikey?
Yes, sir. I see.
Good job. So I have a little narrative here that I'm gonna let it remain so that you can remind yourself of what is required of you. Now, in order to determine the critical points, I will forever say, I have said it so many times, you are going to now substitute the critical values into the original function. No other function but the original. Very important, right? And I went as far as copying the original function there. Anywhere in this function you see x, you're going to substitute x equals -1. Anywhere in the function you see x, you're substituting x equals -1. Honestly.
So does it
So
matter?
this is something different.
It doesn't matter. And -3.
Oh.
So anywhere in the function you see x, remember I'm copying and pasting it, so I have to make sure that I'm reading what it is that I'm supposed to be reading so that I know that nothing is misleading. Right? So anywhere in the function I see that, I'm going to substitute those two critical values in order to work with my corresponding value. All right? So the function is, what's the function?
The function is X cubed plus 6x squared plus 9x plus 4.
Plus 9x. I get myself into trouble every time copy and paste. So I have to make sure that I'm doing what is right. -1. And I'm just typing it now. That's why you see that black screen there. So bear on with me 2 more seconds, please. And then I'm going to press and then I'm going to present it and then look at it and let me know if I'm correct. Plus 6. 1 minus 6 is 5. 5 plus 5 plus 4 is 9. Rockstone plus 9. That is 0. Let me make that right. Okay, that's what I get for that one. Look at x
Sir, I
equals
got
1.
0 and 4.
Look at x equal 1 for me, please, and tell me to got y to be equal to 0.
Yes, sir.
Yes, sir, it's 0. Yes, sir.
Okay. Thank
Yes,
you.
sir.
Yes, sir, it's 0.
Let me just plus 6 times -3 plus 9 times -3 and put that into parentheses plus 4 3 is 9 is 27 -27 plus 6 times 3 is 9 plus 9 times -3 4 7 6 9 4 3 9 27 plus 4 27 minus 27 whoa moving plus 4. I hope I'm right. That's what I have for x equals 3. Check and let me know, please.
Sir, I have that as well.
Great job. Congrats. Everybody has got that?
Yes, sir, I got that as well.
Great job. I'm happy when I hear that. It means that you're understanding. And it means that my labor is not in vain. Thank you for
Critical point.
Oh, yeah, thanks, ma'am. Thanks much. Teacher is doing shortcut. So I just said critical from CR and T and CA. Mikey, how is it?
Yes, sir, I'm okay.
Tariq?
Yes, sir,
Dave?
I'm okay. On my head.
Okay. Where's Leon? Not at class? Come on, what is it?
Sir, I'm good, sir.
You sure?
Yes, sir.
Tony? Rajay? Tony? Rajay? Hold on there. Rajay, wake up. All right. Shetty, how you stay?
Sir, I'm good.
Nice. All right. So we'll have our critical points. And we have then the other part of the question now asks us to calculate the
The y-intercept should be the
first one. So let me calculate the y-intercept first. So of course the y-intercept is found when x equals 0. Don't? It's
Yes,
the opposite, right? It's the opposite one. It's the opposite one that is equal to 0. Oh, see there, I have it. Boy, is teacher nice, you know? Teacher nice. Some may not feel that way, but that's fine. You're lost. So remember to use the opposite one to what is asked. So when it asks about the y-intercept, you can use x equals 0. If them ask about x-intercept, you can use y equals 0. All right? So I'm recalling the function. So it means that anywhere in the function I see x, I'm going to put 0. Anywhere in the function I see x, I'm putting 0. Anywhere in the function I see x, I put 0. And this gives me y equals 4. Talk truth.
Yes, sir.
Sir, I have that as well.
Good job. So my the coordinates of the y-intercept is going to be 0, 4. All right, so we would have done those 2 portions already, stationary point. We now need to do the classification, determine if critical points are maximum or minimum. So remember, for critical points, I'm going to go with the second derivative. Let me just recall, copy what my first derivative is. Let me just colorize it a little bit so you know what it is. So therefore, what is d squared y by dx squared?
Sir, 6x plus 12.
Everybody agrees with that?
That is right.
No, sir.
6x.
No, x squared, oh, 6x, yeah.
Wait a minute, so 6x plus 12. Very
Plus
good.
12,
Excellent.
yes.
Excellent.
I think
Now, I am feeling so much more comfortable now based on the responses from those students who are speaking in class that I can move into my integration tonight. I'm feeling much more comfortable. And thank you for the work that you have put into the stuff. Okay, so we're gonna have 6x plus 12. Now for case one is where copy stationary point is negative 1, 0. So anywhere in the second derivative I see x, I'm going to put negative 1, don't it?
Yes, sir.
Yes, sir.
And that is that result negative or positive?
Result that you will get is a negative answer.
Really?
12.
Negative 1
Sir, I
times.
got a positive 6, so it's minimum.
Oh, positive, sir. I did -3 first. That's why I said negative.
Oh, okay, got you.
Yes,
Understood. All right, so I'm going to have a local minimum. Right here. Remember, when it is positive, it's minimum, when it's negative, it's maximum. And then now for
For the second one, I got negative 18, so it's maximum.
I must make sure to have what is right here, because I don't want to send out the stuff I send out foolishness. Negative 3 and that's plus 12. Negative 3 times 6. Negative 18 plus 12 is a negative number, don't?
Yes, sir.
M-A-X-I-M-U-M. So I get a local maximum for this one. Talk truth.
Yes, sir.
Good job. Everybody else agrees with that?
Yes, sir.
we agree.
Good job.
Yes, sir.
Good job. All right, let me just pause here because the question gets easier and easier as we go along. Remember, students, for the last couple of classes I've been having, I'm saying the same thing and I've been saying the same thing. I think my body is tired, and undoubtedly, I think you are also tired. I really want the Christmas break to recoup, but most importantly, I really want you guys to pass the course. So they have to put in a little 1 or 2 classes, because I know exactly what will happen when the sorrel and the ham and the chicken and the mac and cheese and everything gets to your head. It means that the stationary point can come out of it. And for the efforts that I would have put into the preparation leading up to this point, I don't want it to be an effort in futility. So we're going to have 1 or 2 stuff. It is not compulsory. Please do not report me to say that I am mandated to come out of our class. It's not compulsory. it's an invitation for one study. I will make it that one study. Some invitation. But students, if you choose not to come, that's fine by me. Perfectly fine. But all I'm going to ask you to do is to make sure that you're doing the work. Let me just give you a little tip as to how I became very good at the mathematics. I mean, I've always loved math. I can't think back at a point in my life when I didn't like math. Yeah, maybe when I got to university and math became English, I was like, why did I do this to myself? But anyhow, what I normally do, I will have two sets of books. One where my child goes to school and one that stays home. You know, the one that stays home, you see everything my boy learn at school, boy come home and boy write the question in the home book. And boy study the question when doing a class. And boy write out the question, boy close the school book, and boy sits and work the question in his home book up to a point. If I can't finish the question up to the point, I deliberate over it. Sometimes I leave it and say I'm going to go back to it. And if I'm really, really very stuck, I go back to my notebook and look at the question. I skip the page and I write the question again. And I do this as many times as is necessary for me to get the question right on my own. So I know, so sometimes I'm going into the exam and then give me a question and I say, okay, this is something similar to what it is that I do. And because I do the question so many times, what I could do is write the question that I've done out of my head because I've done it so many times and look at the procedure and just do the other question. So when I'm getting good grades, people may say, oh, in bright, hello, it's practice. It's just practice. And for those of you who were struggling with stationary points, you recognize that the more you do the question is the more you get good at it. It's the same thing that I answer over and over and over and over again. All right, so see how best you can get that one up for me, please. All right, so we've done the classification. Then now, the point of inflection. Remember the point of inflection, I have to find the second derivative, set it equals to 0, substitute into the original function. Oh goodness, it's so I'm going to do that for this one. Sorry. You think you remember the methodology there, or do I need to type it? You think you remember it? Determine the point of inflection. You're going to find the second derivative, set it equals to 0. Oh, but I'm supposed to have that. I think I did that. I think I did that summary for you guys. You know? Oh, come on, Mr. Sean. I think I did a summary for you guys, right? Here goes a summary. I did a summary for you guys. Stationary point, so the point of inflection. Right, so to determine the point of inflection, you're going to use the second derivative, set it equals to 0, and solve the values of the unknown. Then you're going to substitute the values obtained up here so into the original function. Then you're going to write them according to the point of inflection. Very important. All right. Very important. So this is where we are. Oh no. So recall, I'm going to put my recall here. My recall is here. And then I'm going to set my differential equals 0. So 6x plus 12 equals 0. Setting my differential equals 0. 6x plus 12 is equal to 0. Then I'm going to subtract 12 from both sides. I'm going to get 612 is equal to 6x 612. I'm tired. 6x is equal to negative 12. This implies that x is going to be equal to 2, negative 2. Agreed with that?
Yes, sir.
So it has to be negative 2. So 6 times negative 2 is negative 12. Negative 12 plus 12 is equal to 0. I'll pause here for a minute or so just to entertain any questions. Come on, for you, Papa. Come on. Rajay, Dean, Sonia.
No question, sir.
No questions for you. All right. So let's continue. So now it is that we're going to substitute into the original function. Let me go back to the original function. Wait a second. I'm going to be substituting into the original function. I'm putting x equal -2 into the original function. Anywhere in the original function, I see x, I'm going to substitute -2. Is that understood? Can you respond to this another clearly, please? Hmm. 18 and 8, that's 26, 24, 28. What am I doing? Check that for me, please. That's what I got.
So I got +2. Oh, okay.
Are you all with me?
Yes, sir. That's the answer I got.
Nice. Good job. So that's my point of inflection. All right. I don't have a sketch for the class. I can do a sketch for you. This is our application of differentiation. I can do a sketch quickly, just for you to see what it looks like, and then I move on. So I want to work with me. Critical points were what again? Remind me, please, guys.
Critical points. -3/-3, 4.
-1, 0.
And yes, and -1, so.
Point of inflection is -2, 2.
Yes, sir.
Y-intercept.
And the y-intercept is y-intercept 0, 4.
0, 4, sir.
Is there any other point that we used?
No, sir.
Okay, so all those points must be represented on the plane. So the y-intercept is 0, 4. Y-intercept is where it cuts the y-axis. That's what the y-intercept means, wherever it cuts the y-axis. All right? Anywhere along the y-axis, x is equal to 0. And then my point of inflection is, if that is 4, we can call this a 2. We can call this a 1. We can call this a -2. We can call this a 1 and call this a rock stone. And also we're going. Sure. All the way to 4. And also a -3. So what I'm gonna have now is, so what you're gonna have is that I have this point. I now need to put -3, 4, -3, 4, is up here. Something on the right. Right on the right, oh Jesus. Anyhow, let us do the pattern and see what happens. -3, 4 is up here. -1, 0 is down here. I'll put in a point of inflection after. I want to see what the turning point looks like. -3, 4 is what? Is a maximum or minimum?
-4.
-3, 4.
-3, 4 is a maximum, sir.
Minimum, maximum?
Yeah, -3, 4 is a maximum. And -1, 0 is a minimum. So -3, 4 is a maximum. Maximum turn down.
Yes, sir.
All right, so I know the one I turn down, so. And I want to turn up, so. Okay, it makes sense now. I couldn't see the y-intercept. That means that this will come down and kiss the one so. And that means this I could come up so and pass through the one I go up and up there so. But we don't know whether I want to cut the y-axis, the x-axis only so some of this stuff it right there so. And then now so my graph line looks something like so. And then our point of inflection is -2,
Sir, what is it?
Yeah, something right there. So point of
Sir, I was
inflection.
asking, what is it you have for y-intercept?
0,
4.
Okay.
and that's my sketch. Any questions? Are there any questions?
No, sir, no questions.
No, sir.
All right. Moving on. There's another application to differentiation. But I'm not going to do that. I must begin integration. There's another form of application to differentiation. Incidentally, I did it. I did it. Hold on. I did it. Okay. I didn't tell you about this the moment. So I've done implicit differentiation with you already, right?
Yes, sir.
Good. And I show you how to substitute the points in it already, right? Hello?
So you posted a recording on that one because when you were doing it, I wasn't at class. I think it was a
I posted all
face-to-face
the
class.
recordings. I posted all the recordings. Can somebody respond to me, please? Did I do the question where you find a value for dy by dx by substituting the coordinates?
Sir, I don't recall.
Okay.
I'm searching in my book.
I'm sure.
Yes, sir.
Yes, sir.
Shedian.
Did it.
I'm sure
did it.
Shedian responded to my post. And I
Oh,
checked
sir, it was when we were face to face.
Yeah, face-to-face class we did it, sir.
face to face. You're right. No, I did it before face-to-face. I did it before face-to-face, and then when I got to face-to-face, I did a review of it. True or false?
I remember the face-to-face one.
Yeah, man. I did it
Goodness.
before the face-to-face because there's a recording that Shedian made a commented on the recording, and I responded. I replied to her comment. Shedi, did you make did you comment on one of these recordings, Shedi, on the implicit
Yes,
differentiation?
sir.
Okay.
Yes, sir.
Sir, I don't remember that class.
Okay. So that class was the class that got me vexed, why I had to call in the face-to-face class. Haha. Oh, no problem. Oh, no, I have everything here now. I don't throw my notes. So it was that class when I asked about the differential of e to the something to the 2x, and I asked for the differential, and somebody told me that the differential of 2x was 1. And then I was doing this here, and then what I did, I stopped. Anybody remember that I stopped and I went to my notes? Anybody remember that?
Yes, sir.
Uh-huh. I did it. I started the stuff. And I also sent that notes off to multiplier function. Jesus, we should do it. 29. And I sent that off to you. Can't recall, can't find it here in my implicit. Okay. Anyhow, I did this one Thursday. Did it one Thursday. Got vexed because I asked to somebody to differentiate 2x for me. Yeah, 2x for me. I said, what's the difference of 2x? And I heard 1, sir. I was like, after 3 weeks of teaching differentiation, it can't, and it says 1. So we arranged for the face-to-face class. So the question is, the answer to my question is, yes, we did it. So we did, I've already taught you that topic. There's one thing that I need to do with that one, application of differentiation. Oh, Lord, I have too many things open. Right, so I've done this with you, where it is that you go ahead and the implicit differentiation for you to substitute your coordinates in there. The only thing that I now need to show you is how to calculate it at a normal and how to calculate it at a tangent. Oh Lord, I must have a tangent here. Right. How to calculate the equation of the tangent to the curve and how to find the equation of the normal to the curve. So that is like a 5 minutes class technically, because you know how to do the implicit differentiation. I've done that with you. I've done that with you. And thanks again, Tariq and Kamal, for assisting with the video, the face-to-face video. So you have that. So not in such of a bad. Oh Lord. Don't close out anything session because you did some work on this. I need to save it. So let me just go to my differentiation, my integration, sorry. All right. So we're on to integration. We're on to integration. And I need your undivided. This is a new topic. So I need your undivided. Rules for integration and for indefinite integration for that matter. So the following rules for indefinite integrals are obtained by reversing the corresponding rules of differentiation. So what I'm saying to you there that is differentiation is opposite to integration, and integration is opposite to differentiation. One is the reverse of the other. So the opposite of integration is differentiation. The opposite of differentiation is integration. There is no way I can teach you differentiation without talking about integration, and vice versa. So you can't say you're going to know how to differentiate, but you can't integrate. Don't make no sense. Because there will come a time when you're doing your questions and you have to integrate. In order to do an integration question, you have to differentiate and then integrate. Right? The good thing about it is that differentiation, you have different rules, product, quotient, chain, power. Integration has plenty, wholly different forms of integration. But fortunately, we are only going to be doing the basic forms of integration. Thankfully, we're just going to be the basic form of integration. And when I look at it, the integration is actually shorter than the differentiation. And why it looks so? Because, as I said before, it's just an introductory section. The differentiation will go through the whole gamut of it. But for here, because you're only looking at a different section, and I'm giving you the rules here, just as I did for differentiation. Once I go through the rules, you'll be good to go. Let's go. Numero uno. So it says their accuracy is easily checked by taking the derivative of the antiderivative. The antiderivative is your integration or your integral, just to be sure it's equals to the integrand. So if I integrate something, when I differentiate it, I'm supposed to get the integrand, what it is that I'm integrating. So the integrand is what it is that I'm integrating. All right? The elongated S is the sign for integration. See it right there, sir? It's not a S. So please don't write a S with me. It's not a S. It is an elongated S. So stretch your S first before you send it off to me. And the rules are illustrated below. So I'm going to go through these rules quickly. I had promised to send you this document, but of course I forgot. So let's go through this quickly. The integral of a constant K is Kx plus C. When I integrate a constant, I'm going to get, when I integrate a constant with respect to x, dx, when I integrate a constant with respect to x, I'm going to get Kx plus C. When I differentiate Kx, I get K, which is giving me back my integrand, or I can use my, since I'm not writing, I can use my spotlight here. So when I differentiate my Kx, I'll get my K, which is my integrand. I must have my plus C, is known as the constant of integration. You only talk about the constant of integration when it is that you are referring to an indefinite integral. Sir, what really is integration? Thank you for asking. I was waiting for the question from the first time I called the word. So, say for example, your great grandparents will your grandparents a plot of land. Your great grandparents, of course, would have died by now. Your grandparents may still be alive, and they say, you know what? We can't take no loan at my age. Come in and work again. I'm going to will it. The plot of land to your parents. But your parents are still in the country. Them now move come a town because them the town too hard. And they must stay a country go plant them yam and them badu and them support and so on. And them say, oi, see a piece of land here. Come do something for it. And then you look at the plot of land and say, but mama, papa, me not come out of country from me. No one good job in a CEO, I think so. Me not come out from me. But your plot of land is sitting on a very prime area, almost beachfront. And the hotel developers come and say, boy, who own a land here? So boy, I didn't want mass something, you know, but mass something dead enough years ago. And they trace back the land to you and they say, here a plan. Are you interested in selling the land? And for you don't have an idea how much money the land can cost. And you say, yeah, how much you can give for the land? You say, you can give you $20 million. I said, no, $20 million? Wow, me can buy my house in Houston now. And then somebody come and say, no. I'll tell them I'm going to put this up. You can get more for the price of land. Get a quantity survey or go survey the land for you. And the quantity surveyor surveys the land and said, look, this land is valued $50 million.
Sorry, the land surveyor surveyed the land, not the quantity surveyor.
The land surveyor. When I say I love quantity, when I say I love a quantity surveyor?
Yes.
No man, at the land surveyor, you can know if somebody work, you know. At the surveyor? Anyhow. Right. So the land surveyor will come and do the stuff. I mean the land surveyor come do the stuff, the land surveyor will say, no man. No man, I rob you, man. Let me ask you a question. Anybody living in Kingston ever drive up and down or walk up and down and see people some signs that we buy house cash? Anybody see that?
Yes.
Yeah. You know who doing that? Tell me who are doing it.
Scammer.
No man. Well, sorry. Let me not even say no, but let me give them a different name. Developers. And these developers are buying houses from people cash. I know somebody, my music teacher from way back when, may her soul rest in peace, lived in a nice area. Nice area. But guess what? They bought out lands around that area and recognized now that her yard a block somewhere. And then go to the lady and say, here the plan, miss. How you do? She say, oh, good man, what you want? Them say, miss, I want buy your land. She said, but you're out of order. I've lived here for so many years. I said, no, miss, here the plan, man. Hear me out, man. We're going to buy you a house, cash, into an upper scale community. And she said, me have a 3-bedroom house. I said, no. And she said, no, what about it? I'm going to buy a 4-bedroom house. And they bought her and relocated her to a different property in exchange for her property. But if I take you to that property now and show you the monstrosity of a housing scheme, gated community that they put there, developers, their money can't done. Them have the money cash. So if you say to them, say, the plan, me no want you relocate me, you know. Got me a plan for migrate. How much you can give me for the place? It's about $35 million more, you know. So you can't renegotiate. $35 million more. Okay, don't worry about it. And believe me, I'm not kidding you. You will get your $35 million cash because they have money sitting on. So guess what happened? Let me go back now to the prime land. So the land surveyors come and the land surveyors look at the stuff and say, no man, this is prime land. The man at least at $20 million, give the man one, give $50 million with the price tag. The quantity surveyors come and then look at the land and say, yeah man, it is on a good slope. The soil underneath is good. You have very good structure, mean that it's not sand, it's not clay, but it's good bedrock. Them say, yeah. And NEPA come in and NEPA say, yeah, man, it's solid, man. It can't take a 5-story building. Hello? The next thing you see is a hotel right there. And this is not what I'm asking you, because one of the areas of my study is in this area that I'm telling you about. So I'm speaking out of a position of authority. There are several buildings developments in St. Anne for argument's sake. One of them, won't call the name, but one of them I went and spent some time at pretty recently. The moment I went in, checked in, and decided to walk over the property, I started to get very upset. My spirit was upset, and I started to rant and rave. Why, sir? Because I was able to identify many dead coral reefs. You may wonder to yourself, sir, how does this relate to mathematics? But you will see what I'm talking about. Many dead coral reefs, because I'm walking along the beach and I'm finding corals. And of course, you have to have an eye for coral to decide that it is coral. I said, no. So I started picking up the corals. And I'm saying to myself, something is not right. So I walk the shoreline. And the further out I go on the shoreline, I am finding more and more corals. And then I got very upset. Took it back to the room, and to the point where I have those corals that I picked up, I have them at my yard to this very day, this very moment I'm speaking to you. The following day, I went back out, and I was able to find more corals. And then I said to myself, all right, sit down. And I was reflecting. I do a lot of that. Me and God have a nice little conversation. And I said, you know what, God, what is happening right here? You know what happened? The people then dump up the land because of this global warming. The people then, the sea line is regressing, and the people then dump up the land so that they can extend the beachfront property. So when I went out to the barge and I looked down, it's concrete I'm seeing into the water. And I got very upset, to the point where I met one of my batchmates from UA, and we were having a conversation, and he studied an area that I studied, and we were there talking, and he's now one of those policymakers. I'm saying, take time talk, because this is politics. When I go to these meetings, I cannot complain. I said, but it is wrong, it is wrong, it is wrong. What's the point? You have a small piece of land in a country, and it is prime land. What these guys are going to be doing is try to get permission from NEPA to go and dump the land so it is that they can build. So I'm going to tell you this before I tell you how the integration comes into this part. Whenever you go to these hotels along the St. Anne beachfront, I'm not going to call on names, you know a whole host of them, big hotel, little hotel. I guarantee you, especially if you can walk like 2-3 meters out into the ocean and the water just catch you at your waist, they dumped the land. It's not good for the environment. So with that said, I just rant and rave a while ago. With that said, what the guys do is they would have integrated to find the area under that plot of land. So we speak about the area under the curve. It is the integration. So they know what amount of space that they have to work with. Let me fast forward a conversation to you. I saw something in the papers that say Kingston must brace themselves now for more high-rise buildings. Problem. Kingston is going to get hotter and hotter and hotter because these high-rise buildings, just imagine you have one little house between 2 high-rise buildings. He's going to kill you. Heat is going to kill you. You better get air conditioning unit. And you better, matter of fact, depending on where it is located, you may even, the sun may be even blocked from your area. And if you have solar panels, those panels may not be able to charge fully. So these are things why these authorities are out there, NEPA and the environmental agent, other environmental agencies out there, and land surveyors are out there, to guide these people as to what it is that they're doing. But I guarantee you, if you look at a resident, one single resident, one single resident, when the developers come and buy the plot of land from you and demolish the house, they are going to build an apartment. And sometimes they get 10 units out of the apartment. And you're going to say, but sir, what if each unit has 2 cars? Or you're going to get 20 cars parked. The man them smart. The man them start parking underground. Underground. Anybody knows the Mountain View area pretty well? Anybody knows Stanton Terrace? Talk to me. Hello?
No, no, sir. No.
Yes, sir.
You don't know Stanton Terrace?
Somewhat.
Hello? Stanton Terrace. Sometimes you have to pass Stanton Terrace. If you take the 83 bus, or go down and exit. All right. So there's a reason I asked it. So coming from Harvey, you pass Fairwell. You come across Stanton Terrace here to make the right turn to go down to Mountain View. You see there is a building that is right across that intersection there. It's not Tucker Avenue, it's the other avenue. That was called Priority House. No, I used to carry my car over there to be assessed, so I can pay my insurance every year. One little old house, one little old house. And every time I drive there and I look at the monstrosity of a building that they got out of it, to the point where one day I passed and I saw the old house. The following morning I'm going to work. The whole house wasn't there anymore. I was like, Rockstone, how did they do this? You know what the man them do? They dug deep down. They calculated the area under the curve to see how far down I can go. Because you see, when you go down, the further down you go, then you're going to talk about an aquifer. So if you have an aquifer, which is our groundwater reserve, you can't build a high-rise building from that, because at some point in time it's going to sink. So if you find bedrock, remember earlier in the conversation I said to you that it has to be like bedrock, good type of soil, not clay soil or sand, good soil where it can withstand the structure and if you have earthquakes support and so on. That's what the guys did. They found good soil under there. So the parking is underground and they have a monstrosity of a building. And that's what it is that they have done. So they know the area that they have. They know how much them can go down under. So it is that they're going to be using that. Let me give you a pictorial, new share. Let me give you a pictorial as to what it is that I'm talking about. Which documents are using it for that one. So application. Right. So this here is an application question to integration that I have not yet done because of course I'm just teaching you integration. So the question says to find the total area enclosed under the curve. So if you look at what I'm talking about, this may be a plot of land from this point here. This plot of land is from this point here. So this is number one. Sorry, from here to here. So this is. Sure, come on, get it box together. This is one resident. Then you have another resident from this to this. Then you have another resident from this to this. So is this going to be -1 to 0 to 1 to 2? So you have here so as a resident. So you can build a house. You see this X line right here, so from right. By the way, are you seeing my screen?
Yes, sir. I've seen a screen.
Right, good. You see from this point here, so where you see the pencil? To the point right here, so this is a plot of land that you can build all the way up, right? As prescribed by NEPA, because of course you have to have them coming and doing them stuff to tell you exactly what it can do, support, and what it can't do. But because of you just having this space alone, they're saying it is important that you have your underground parking. And some newer developments, what they're doing, they're putting, because of the area that you live in, they may put water tanks even further underground. So they go even deeper than the car park to put your water tanks, your metal water tanks underground, and then pave it off and just put your parking space there. So this is what I'm talking about. You see this blue line that come under here, so?
Yes, sir.
The surveyors may say, this is the furthest you can go. Because if you go any further, you're going to interfere with the groundwater reserve, or you have a different soil structure down here, so it can't happen. So this is the furthest you can go. So the surveyors will look at it and say, this is what needs to happen. So them say, yeah, man, this is big enough space, man. So under here, so where you see the little green something, under here, so I can work with it. So this is what the question is asking. So everything I'm talking to you about now is going to be is in reference to the application of integration. So I can find the total area enclosed between the curve and the x-axis. See it here, so it's from x equals -2 and -2. Okay, it wanted from -2. Let me just clear right here. So it wanted from -2 all the way up to +2 here. So it wanted from this side, right? Sometimes your land space may shape differently, and you may not get a full square. Sometimes your land shape may be a trapezoid, whatever shape it is, right? So this area under here, the area under the curve, that is integration. The area under the curve is what these new developers are using so that they can build your underground storage, the underground car park. Very important. So what they do, they are maximizing the little space that they have in Kingston. Absolutely. And you see, and part of the problem, Tariq, is many times when we are learning these topics, we don't learn the real life application to them. So we are learning in isolation. Where am I looking at? We're learning in isolation. So we're really not understanding what it is that we're doing. We're just doing it because of doing sake. When you can have an understanding and an appreciation of what it is that you're doing, it makes learning so much more fun, and you can understand even so much better the things that we are doing. All right. So that is going to be the application to differentiation. So when you drive around a town again, anyway, our country too, and you see what the strips were going, you know so it's mathematics that is involved in all of that. All right. All right. So when I'm integrating, remember now that I am going to have the constant of integration is going to show up only when I'm integrating an indefinite integral. And I will show you what an indefinite integral is. All right. Rule 2, the integral of 1 written dx. I'm not going to write it as 1 dx. Never ever write this here as 1 dx. That don't make no sense. It's like you're talking about reverse back. And repeat again. And the rain is falling. Redundant. So if you integrate in 1, we're just going to write dx. So see it here. So it's the integral of dx. Then you're going to get x. And of course, you're going to have your plus c because it's a constant. It's an indefinite integral. Rule 3. I put rule 3 in green because rule 3 is really the essence. Is really the essence of integration. Is really the essence of integration. Watch me. Don't blink yet. You have a power function x to the n. N is not equal to -1. Just be reminded that n is not equal to -1. If n is equal to -1, we have to go to something special. If n is equal to -1, we have to do something special, very special. So look at what is happening. The integral of x to the n dx. The integral of x to the n dx. For integration, you add 1 to the power and divide by the new power. Watch me. You add in 1 to the power and you divide by the new power. And of course, your plus c. When you're differentiating, what do you do again? When you're differentiating, what do you do?
So you add to the power.
When you differentiate, right.
Oh.
So when you're differentiating, you are subtracting 1 from the power. See, I'm only emphasizing the point, son, that 1 is the reverse of the other. So when I'm differentiating, I'm subtracting 1 from the power. When I'm differentiating, I'm subtracting 1 from the power. But when I'm integrating, I'm adding 1 to the power. But I don't finish there. I'm going to divide by the new power. I'm divided by the new power. So note, we're adding 1 to the power and then divide by the new power. It's very important. Important to know. And I'm going to promise you, before we leave class tonight, in the next hour and 4 minutes, you're all going to learn how to integrate. And I've already told you about the application to integration. So I've covered that section already. So when we finish that, then we can jump into the application part. Let's go. So I did say to you in rule 3 that your power, your n, cannot be equal to 1. Cannot be equal to 1. But sir, life is not black and white. You have some shades of gray. I agree. Let me ask you a question, sir. What if n so happen by the slimmest of margins to be equal to -1? Thank you for asking me. Let us look at rule number 4. So you're doing the integral of x to the -1. You understand, sir? So you can't do it. Watch what I'm doing. I'm going to convert it to 1 over x. Is x to the -1 the same thing as writing 1 over x?
Yes, sir.
Yes, it is. The laws of indices, right? So I'm writing it as 1 over x. Now, when I see the integral of x to the -1, I am jumping to the logarithmic function. Oh my goodness. It's the first time seeing the logarithmic function. Is that a true statement? Is it the first time you're being introduced to the logarithmic function? ln?
I think I did that in discrete math. I should think.
I think you did it in calculus 1 too.
You remember when?
You don't remember when? And then some people that call it 1n. The same person who just said don't remember when. in rather, you're calling it in. And I said no, it's not in. No, yes or no?
I remember, sir.
You don't remember? All right, no problem. That's fine. We have so many things on our heads that we may not remember a lot of them. All right, let me just try and refresh your memories. Trying to find, Lord, help me, Lord Jesus. Where was this? This was differentiation. This was differentiation. This is differentiation. Differentiating the exponential function, the logarithmic function, and the square root function. Okay, let me share. Anybody remember the exponential function? The differential of e to the x is e to the x. Anybody remember that?
Oh, yes, sir.
Okay, nice. Thanks for remembering. Anybody remember the logarithmic function? The differential of ln x is 1 over x?
Yes.
Anybody remember that? No? It rings a bell now? I hear lots of laughing. So it sounds like it rings a bell. The rest of it, listen to me. Want to talk to me. The rest of you, where are the rest of you?
Yes,
Come on.
Sir. Yes, sir. Sorry for not responding.
Sure. Yeah, man. I know it should ring a bell. Yeah. So we did it. I really hope you're paying attention because sir is really building or has built. So we did all of those, and we did some past papers with the ln function, And we see that the integral of the ln function is always 1 over the function times the differential of the function itself. Remember, we had all that conversation. And we talk about the square root function, and we did those. So those are the 3 functions we did one night.
Yes, sir.
All right, good. So now I can close this one because it refreshes your memory. Thank you, Lord. So now let me go back to my share screen. Oh, stop sharing. Let me go back to my share screen and bring back my integration. So yeah, man. So we're coming back to the ln function now, right? Which is our logarithmic function. So when we're integrating, when we're integrating, I'm sorry, when we're integrating x to the negative 1, that now comes into the logarithmic function. Sir, why? Because remember, when we differentiate ln x, we got 1 over x. See it right here, so remember, one is the reverse of the other. So 1 over x is the same thing as x to the negative 1. See it right here, so if when we integrate x to the negative 1, we get ln x, it means that the differential of ln x has to be 1 over x. You know the differential of ln x to be 1 over x from a couple of weeks ago. So when I integrate 1 over x, I'm supposed to get ln x. Why, sir? Because 1 is the reverse of the other. Now note, x has to be greater than 0 in this case. X has to be greater than 0. Why? The condition for x greater than 0 is added because only positive numbers have logarithms. I cannot, not in this life, nor the next, find the logarithm of a negative number. Logarithms, only positive numbers have logarithms. For negative numbers, because life is not black and white, you have some shades of gray. For negative numbers, I'm going to be using the absolute value. Okay, absolute value, sir, 2-stroke in a something. I know you get a lot of absolute value questions in discrete mathematics because I think I know the syllabus. So you get absolute values in discrete math, right? But so if the value, if x is less than 0, you're going to be using the absolute value. But if not, you can just forget about that. All right. So if x is less than 0, not equal to 0, right? I'm going to use the absolute value. I'm going to be using the absolute value in this case, right? You may say, sir, you reach rule number 5 now, and I don't have a clue what you're talking about. I don't have a clue what you're talking about, and that's fine. When we start doing the questions, as I promise you, you're going to see what is happening. No, sir, you just remind me about the exponential function. Yeah, man. Just as how we differentiate the exponential function, we can also integrate the exponential function. So you did say to us that the differential of the exponential function is the exponential function itself times the differential of the power. The integration, listen to the story here. The integration of an exponential function is going to be the exponential function itself. You're going to differentiate the powers, just like the differentiation, you know. But instead of just multiplying by the differential of the power, you're going to multiply by the differential, the reciprocal of the differential of the power. So in differentiation, if I gave you e to the kx, you're going to differentiate kx to get k, and so that being k e to the kx. For the integration, you're going to put 1 over the k. So that's the difference between the integration and the differentiation. Let me say that one more time. When you're differentiating an exponential function, the differential of an exponential function is the exponential function itself. The differential of an exponential function is the exponential function itself. All right? Times the differential of the power. So you're going to differentiate the power and multiply by the original exponential function. That's what the differential of the exponential function is. When you're integrating an exponential function, on the other hand, many of the rules remain the same. Like differentiation, the integral of an exponential function is the exponential function itself. Same thing. You're going to also differentiate the function similar to what you do with the differentiation. you're going to multiply similar to what you do with the differentiation. The only difference is for differentiation, you are going to be multiplying by the differential of the power. For integration, you are multiplying by the reciprocal of the differentiation of the power. So instead of just multiplying by k, you can multiply by 1 over k. You're going to multiply by 1 over k. Am I understood right there?
Yes, sir.
All right, and then I have like
Yes,
2
sir.
more. Good. The integral of a sum or a difference. This is like the chain rule, you know? So look at it. It says f of x, the integral, remember the elongated
Sir?
s? Yes, Papa.
Sir, are you skipping a rule, rule 6?
Oh, I skipped one? I'm very sorry. Oh, thank you for paying attention, son. The integral of a constant. K is a constant. So when I integrate the constant, k, when I integrate the constant k, f of x, I can take out the constant. I can take out the constant. I don't have to integrate the constant because a constant is a constant is a constant. I don't have to integrate the constant. I can take out the constant, but when I take out the constant and I do my integration, best believe that I have to multiply it back by the integral. All right? So if I give you 3x and I ask you to integrate 3x, I can just go ahead and just integrate x. And when I integrate x and I get the answer for the integral of x, I just multiply back my answer by 3. Instead of me just going ahead and integrating 3x. All right, that's what it's saying. Rule 7. The integral of f of x plus or minus g of x, it means that if I'm integrating f of x plus g of x, I am integrating f of x plus the integral of g of x. If I'm integrating f of x minus g of x, I'm integrating f of x minus the integral of f of x. So it means that I can just integrate them individually. That's what it is saying. So it's like we do the chain rule in differentiation, where we differentiate the functions individually, are the same thing in this stuff. For integration, I can integrate the stuff individually. And I'm going to show you what I'm talking about. We're jumping into the example now. I think I have 2 more. It's a rule 6 and rule 8, they're related. Because rule 6, the constant here is k. The constant here in rule 8 is a negative sign. So if I have a negative sign here to integrate, best believe that I can take out the negative sign, do my integration, and then multiply back by the negative sign. Press pause. Press pause. One of the things that I love about teaching, I actually love teaching. I may not lie to you. Sometimes I think I have a mind of an elephant because I remember scenarios that I can't pull back on. I gave you an example when we had face-to-face. It was on implicit differentiation too. And I said to you, when I'm integrating, I'm taking out my negative sign and I'm putting it into parentheses. Then I'm going to differentiate. And when I differentiate, I'm going to redistribute rather the negative sign over the parentheses. And to the right of the board, I was writing something over negative 19 over positive 19. And when I finished my final answer, nobody got the answer. Anybody remember that scenario in class?
Yes, sir.
Come on.
Left out the negative.
Because when I left out the negative, there was a negative. So what you guys did, all of you, as a matter of fact, did, was to apply the negative sign only for the first term, but did not apply the negative sign to the second term. So I keep saying to my students, don't fall prey to that. Whenever you have a negative sign, use up the parentheses. So this is what this integration one is saying to you. This integration one is saying that I can go ahead and I can factor out my negative sign, do my integration, so I'm going to make no mistake. But remember now, when you finish that, you're going to multiply this negative sign through everything. So that's what all of that is saying. All right? So don't forget. Don't forget. All right, here goes. So there are 8 rules. Finish the rules, sir. You finish them. I don't remember not one of them. Not a problem. You know what is the good thing about it? I would have gone through those rules with you. So when I'm doing the question with you now, the questions with you now, I'm going to reference the rules. And I can guarantee you before the end of the class, you will be able to memorize 1 or 2 of those rules. All right, watch me. I'm talking about indefinite integrals, of course. It is asking us to integrate 1 over x squared. Oh, but sir, we never see it talking about no quotient rule, you know. You're right. But for another quotient in the integration, we can convert it. So you see this 1 over x squared, and I should say we do have a quotient at this level. At this level. Because you will be given questions as a quotient, but the methodology that you're going to be doing or applying in order to do the question is to convert it into a negative index. So this 1 over x squared dx, when I rearrange it, I'm going to get x to the minus 2. I'm going to get x to the minus 2. Then this is what I'm going to integrate. This is why it's called an indefinite integral. I should point that out. It's called an indefinite integral because I don't have any power up here. So any term, any upper limit or lower limit. So why call it upper limit or lower limit? This is just like for your house number 10 and your neighbor at 12 and the neighbor up top at 8 and the neighbor across from you at 9 and the one across from them at 5 and the other one at 7. Yeah, man. Those are the numbers, landmarks. So I don't have any upper limit nor lower limit. It just blanks up. Right? That's why it's called indefinite. So I'm going to integrate. Remember the rule says you add 1 to the power divided by the new power. So it's going to be x to the negative 2 plus 1. I am adding 1 to the power and I'm dividing by the new power. I'm adding 1 to the power and I'm dividing by the new power. I'm adding 1 to the power and I'm dividing by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Don't forget that. For integration, I'm adding 1 to the power and I'm dividing by the new power. Remember, new power. So watch me. So this is x to the negative 2. This is the original question, x to the negative 2. I'm adding 1 to the power. So it becomes plus 1. See if I took this up? So we're going to have x to the negative 2 plus 1. Rock stone, but so you know, so we must divide by the new power. The new power is now 2 minus 2 plus 1. See it, so? Minus 2 plus 1. So add 1 to the power, divide by the new power. And I must have my plus c, my constant of integration. So watch me now. Negative 2 plus 1 is negative 1. So this becomes x to the negative 1 divided by negative 1 plus c. I'm going to simplify. Remember, c is my constant of integration. I must include my constant of integration. Sir, what is this constant of integration? Thank you very much for asking. I've been saying this over and over. Nobody don't ask me. So because I don't want you to leave the class without you knowing. The constant of integration is because I don't have my upper limit or my lower limit. I need more information in order for me to decide what is happening. So Kianda may say, I live on Love Lane. Okay. How many houses on Love Lane? Plenty. So you don't tell me what number? No, I just live on Love Lane. So no, I would need more information to be able to point out which house on Love Lane Kianda lives. So she may say to me, coming from this direction, the house is going to be on the left-hand side. That's one piece of landmark. And she may say to you that there is a big mango tree in the front of the yard, and there are some evergreen trees. Matter of fact, she may be even specific to say There are 5 evergreen trees on the lawn. So you go drive. You go drive and you go look out for the evergreen trees on the lawn. And you go count 1, 2, 3, 4, 5. You go look for see one big mango tree on the something and say, you know what? This fulfills the landmark. Kianda, yo! All right, me outside. Good. Those landmarks will convert this indefinite integral to a definite integral. So the next time you go for your house, you don't have to drive slow. You can drive fast because you know exactly where the car is supposed to stop. And that's why whenever you're going somewhere that for the first time, the journey is longer. Anybody ever recognize that? When you go somewhere you don't wait longer, but when you come back it's shorter? Talk truth. Anybody, somebody.
Yes, yes, sir. Sure.
Come on. You go somewhere you don't know where you go. The journey it may take you half an hour. But when you come back, it may take you 20 minutes. It's a blow, it's shorter because you know where you're going now. When you're going back to the other place, for example, when I drive to Portmore, Portmore is like going next door because Portmore not far again. It's not far again because you know we are going to Portmore. All right. Okay. So that's what the plus C is. The plus C means that I need more information in order to determine which road, which house on Love Lane I must stop to reach Kianda. All right, I must get that information. If I don't get it, it's going to be a mystery. All right, and then now, I just evaluate my stuff. This is going to be negative x to the negative 1 plus c. Remember, I said to you long time in mathematics, you never normally write your answer as a negative index, so I can reconvert it and put 1 over x to the positive 1, negative 1 over x to the positive 1 plus c. That's all that there is to it. Let me pause right there and ask, are there any questions to what I just did right here? You think you're following? You think it makes sense? You can see your way through that one so far? You may not fully understand it yet, but at least you see your way here. Do I have a yes?
Sir, I don't understand.
Sorry, I heard Courage first. Let Courage go ahead. Courage, I'm coming. Go ahead, Courage. Let me hear what you're saying, hon.
Yes, sir, from the minus x raised to power negative 1. Yeah, I don't understand how you got that.
You don't understand how I get minus x to the negative 1?
Yeah, what happened to the denominator?
This negative sign is Courage. My dearest student, remember,
Is it that you multiply it and then the power, you minus the power?
My dearest Courage, remember in our face-to-face class, it's either you or somebody, I think it's you, that said to me, no, sir, I got, like you said, 19 over negative 3. And I explained to the class, 19 over negative 3, 3 over 9, negative 3 over 19, or negative 3 divided by 19. That it all means the same thing. Anybody remember me saying that?
Yes, sir.
Yeah. So if your denominator is negative, the whole fraction becomes negative. So if you have negative 1/2, if you have negative 1/2, if you have negative 1/2, negative 1 over 2, but somebody else wrote 1 over negative 2, and then somebody else write negative and then put 1 over 2, it means the same thing. It means the same thing. Okay, sir.
Yes, sir.
You understand it now, dearest? No, I was just trying to think of something else to say to you, but do you understand what I'm saying right there? So if you look at it here, oh sorry. If you look at it here, this -1, when you divide a function by 1, 2 divided by 1 is the same thing as what?
2.
Very good. So you see this negative sign? I'm just carrying negative sign in the numerator. Because if the negative sign is in the denominator, the fraction is still negative. So I'm gonna have negative x to the -1 over 1. But x to the -1 over 1 is the same as x to the -1, because when I divide by 1 is the same value. So I'm going to end up with negative x to the -1. Are you seeing that? No? Yeah?
Yes, I understand now, but what if that -1 is -2?
No,
Is that you bring the 2 to the front?
it's going to be, no, because the 2 there is going to be a half. Once the number is in the denominator, remember it's reciprocated. So what you'll have is a negative x to the -1 over 2, because you're moving the negative sign there. So if you have a 2 here, this 2 in the denominator is telling that you have 1 over 2. If you have a 5 there, it's 1 over 5 that you have. So if you pull out the 2 right here, it's not going to be -2. It now becomes -1/2. So this one here, this -1 here, is really -1 over 1. And -1 over 1 is the same thing as -1. And I don't have to say -1, I can just say negative, which is what this negative sign here is. Follow?
Yes, sir. Yes, sir.
All right.
Sir.
Yes, Papa.
So you're referring to the coefficient of x to the -1.
But just like when you use my terminology, make me feel like I teach. Yes, sir. I'm referring to the coefficient of that. Yes, sir. I like it. That's what the math class supposed to do. Supposed to speak the jargon. Very good. Everybody's okay? Joe, I think you're coming in.
Sir, I was going to ask you to like if you could explain again, but like
I got another question.
yeah, that's what I thought, sir. But,
Yeah, Tariq, I saw you unmute just now. You're going to say something?
I was going to say, no more question. Yes, I understand now that they explained.
Okay, bless you. And it just re-emphasizes the point, how important it is to ask a question. So it's that kill 2 birds with 1 stone. All right. This question. Yes, son.
I sent you a message in the chat.
All right, thank you. I saw look at it. Give me half a second. I'll just populate this one on screen. All right. Now that I've populated it. Okay, let me share my. Okay, no problem. Okay, Dean. I've just populated a question and I'm going to ask you undivided. Want to know, want to blink, because this one here looks long. 1, 2, 3. The fourth line I have to write up, and then a line in blue is my answer. Then insert the question longy, because by the time I finish class in another half an hour, you're going to be able to move from this line up here, so with a question, skip out all of this and jump to the line down here, so. And I promise you, but the only way you're going to be able to do that is if you pay attention. So if you don't know how to do it within half an hour, it means that you weren't paying attention. Let us go. Somebody saying something?
So I was going to say, I remember that my teacher told me not to skip any steps when doing the answer.
Oh my goodness, I wonder which teacher is that. I have to be careful of the things that I say in class. But no, man, in this case, this is going to be possible. All right? Let's go. I promise you. Look at this. So this says this is the integral of 3x cubed minus 2x to the 4 plus 7x minus 2 dx. Okay, sir, I'm supposed to be integrating. I'm looking at rule 7. Rule 7 says, never integrate the first piece. See it here, so I'm integrating 3x cubed dx plus I'm integrating negative 2x to the 4, see it here, so dx plus I'm integrating 7x dx plus I'm integrating negative 2 dx. That's what it is. That's what rule 7 tells us. That's what rule 7 tells us. All right? So when I have, remember I was saying to you, like when I have the chain rule, it means we integrate individual terms with respect to x. I eat this. And then now you can have some constant rule business when we come out. You want to rule 8. So look at what happened now. All of this, I'm going to write it back so. And then I recognize that this is a negative sign. I want constant, I can draw it out. Now when I draw out the negative sign is going to supersede the positive sign. So it has to become a negative sign out here. So, and then I also have the 2x to the 4 dx. The one you know are the same something. So I'm just going to put it back there. So. And then this one, I have a negative sign. I'm going to draw out the negative sign and fling out a door. When I fling it out a door, I'm going to beat up the positive sign and to go supersede it. So I'm going to have 2 dx that are rule 8. Then I look on it again and say, but hold on. 3 and 1 constant. I can all out the 3 too. Yeah. I can all out the 3 and put out a door. See it so? And just have my x cubed dx right there so. But hold on, sir. If you really look on it, you can all out the 2 same so. But all out the 2 and put out a door. Sir, why you all out the something them so? Because they are constant. I will look at the rule that says they are constant. So I'm going to have x to the 4th left with the dx. Rockstone. Sir, that the 7 can haul out too. Same way, so. So I'm taking out the 7, and I'm just going to have the x dx right here, so. And the same thing I'm going to put to the 2. But sir, when you take out the 2, not going to leave. Remember, when you integrate in 1, we don't say 1 dx. We just say the integral dx. See it right here, so. So we just take out the 2. So this is what it is. And this is going to be a combination of rules 6 and 2. All right? And this one here is the rule 2 one. All right? Then recall, we're going to add 1 to the power divided by the new power every single time we integrate. We add 1 to the power, we divide by the new power. We add 1 to the power, we divide by the new power. Still don't blink, because it don't notice it now. Watch me. The 3 may I hold it back down here so because it's going to use to multiply everything when we don't integrate. Now add 1 to the power divided by the new power. Add 1 to 3, we get 4. X to the 4 over 4. See that so? X to the 4 over 4. Done. The negative 2 here, we can come right there so. Add 1 to the power divided by the new power. X to the 5th over 5. See it right here so? X to the 5th over 5. The plus 7, we can't back out here so. Because it's the constant, not going to use to multiply everything. See the x right here so? Add 1 to the power divided by. Sorry, this one do have no power. Yeah, man. Even when they say the power will be 1, but we don't have to write the 1. So there's an imaginary 1 up here so. So 1 plus 1 are 2. So this is going to be x squared over 2. See right here so? X squared over 2. Let me see you do that one, sir. This is x to the how much?
0, sir.
Oh, Jesus. I love when you eat lunch. X to the 0. And I remember doing a question like this in class one time, and I did put it in green. Anybody remember this? All right. When I was doing the differentiation and was introducing the differential of a constant, and I said the constant is x to the 0, and I had it in green. So because this is x to the 0, 0 plus 1 are 1. So it needs to be x to the first over 1. See here? It's going to be this x. And then I must put my plus c because I'm talking about the constants of integration. I must put my plus c, constants of integration. Sir, did you say it done with the blue? Yeah, but me can just kind of fix up the fish. So look what I'm going to do. 3 times x to the 4th over 4 is the same thing as 3x to the 4th over 4. See that, sir? 3x to the 4th over 4. Negative 2 times x to the 5th over 5 is negative 2x to the 5th over 5. See that, sir? Negative 2x to the 5th over 5. Plus 7 times x squared over 2 is simply 7x squared over 2. See that, sir? Boom. And the negative 2x are the same, so on the plus C. And the question done. Tell me, is that difficult?
Sure, that difficult.
Okay, all right.
That difficult. I have some more practice.
All right, no problem. And I'm happy that you say, watch me now. Here goes number 3.
Sir, hold
I'm telling
on. Sir, the question finished right there, like, work for the 3x
the
to
question
the
is
4.
question is finished.
Okay.
Question done. That's what I say in my heart. Come, because I promise you, say, you didn't catch something else. I'm moving on to the other question because I can see what is happening. In this here case, similar to the one before, we have to integrate 4x to the 5th plus 7x cubed minus 6x squared plus x minus 9dx. The rules for integration say we can integrate the 4x to the 5th, put it down, integrate the 7x to the 3rd, put it down, integrate the negative x squared, put it down, integrate the x, put it down, and then integrate the negative 9, put it down, and then when we put down all of them, something that we've done to the integration, we can gather all of them together and put them back together and make a final answer. Was that what I did up here, sir?
Yes, sir.
All right, so watch me now. Watch me. And tell me, I want you to look, I am integrating 4x to the 5th. One term. Do you agree with this?
Yes, sir.
And then we're going to have the 7x cubed. I'm going to try to colorize it, that. And then this now, a plus negative 6x squared, see it, so boom. And then we have the x, boom. And then the negative 9 plus the integral of negative 9. Same thing as root 7 as up top of yourself. All right? And then now, we will say, but the 4 is a constant, we can't take it out. So we take out the 4. I'm just going to have x to the 5th dx. So you have to write the dx, yeah, because I'm saying that I'm integrating this function with respect to x. So when you have dr, the question can't work because there's no r right here, so, all right? And then the 7 now is a constant, so we can't take it out. I'm going to take out the 7, we just have the x cubed right here, so. Uh-oh, the negative 6. But in the first example, sir, you need to take out only the negative sign first, and then you take out the 6 after. So we can take out the 2 of them one time. So we're going to take out the negative 6. Remember, the negative sign is going to supersede the positive sign. So this negative 6 I'm going to have in here, so I'm going to come right out here, so as negative 6 right here, so. And I'm just going to have the x squared left inside here, so with the x, with the dx. Uh-oh. This remains as it is because we can't take out on. There's no constant term right here. But sir, there is a constant term right here, so negative 9. So I take out the negative 9. Remember, I don't write a 1 inside here. Remember, rule number 2 says we don't write 1 dx. We just write dx. So since I took out the negative 9, I put the negative 9 right here, so, and I just write the integral of dx. I know that there's a 1 right here, so but we're not going to write it. Rule number 2. All right, that's what I tell you. So when I finish, we know the rules then. Recall, we're adding 1 to the power, we're dividing by the new power. We're adding 1 to the power, we're dividing by the new power. Watch me. The 4 here is a constant. We're taking it out. Now I'm going to integrate in here, so add 1 to the power divided by the new power. 5 plus 1 is 6 divided by 6 here, so x to the 6 divided by 6. But remember now, when we're integrating an indefinite integral, I must have my constant of integration. So when I write the x to the 6 over 6, I must have my plus c. See right here, so plus c. Done with that one then. Move on to the next term. Plus 7 c here, plus 7. Then I'm going to integrate now this x cubed. Add 1 to the power, divide by the new power. X to the 4th over 4. See it right here, so? But this was an indefinite integral, so I have to put my plus c. See it right here, so? Done with them 2 terms at the next one. Uh-oh, this negative 6, I'm going to carry it back out here, so? Have it out here, so? Then I'm going to integrate my x squared. Add 1 to the power, divide by the new power. X to the 3rd over 3. See it right here, so? But it's an indefinite integral, so I have to write my plus c. See it right here, so? Move on to the 4th term. X. Uh-oh. When I say x is x to the 1st power. So 1 plus 1 is 2. So this becomes x squared over 2. See it right here, so? And it's an indefinite integral, so I must add my plus c. Negative 9, we write it back. Uh-oh. 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 X to the 0 is 1. Anything raised to the power 0 is 1. But x to the 0, 0 plus 1 is 1. So it's going to be x to the 1 over 1. And x to the first over 1 is the same thing as x. C right here, so plus my c. Now, I want to show you something. You see that little c here, so in a green, right here, so plus the orange c right here, so c right here, so plus the black c right here, so c right here, so plus the color C here, so but like purple to me, no. The color C here, so it right here, so and the C right here, so and it right here, so I will equal to 1 big C. Constant plus of constant plus of constant plus of constant plus of constant is still a constant. Please do not write 1C plus 1C plus 1C plus 1C and write 5C. It's
So you
just
know
C.
that it didn't mind. I think it has a 5C equal to a
No.
big C. So
Yeah.
anything so
Yeah.
that
I just see. Right? So that's just the point I'm making right here. And then now, and that's rule 3. We finish the integration, we just have fixed it up now. So remember now, the 4 here, I'm going to multiply everything right here. So 4 times x to the 6 over 6 is this. 7 times, so when I write about the c, remember all of them is a c here. I'll go add up to give me a big c right here. So, all right. 7 times x to the 4th over 4 is here. So 7x to the 4th over 4. Minus, can't leave out the negative sign. 6x cubed over 3, see here? 6x cubed over 3. X squared over 2, x squared over 2. And this took me a while to do all of these questions in color so that you can see it pictorially. All right? Minus 9x plus my c. So the answer finished here, so now? I mean, I can fix it up a little because 2 can go into 4 and 2 can go into 6. So 2 into 4 goes 2 times and 2 into 6 goes 3 times. I'm reducing this fraction right here. So this 7x over 4 can't be reduced any further, so I write by the 7x over 4. This can be reduced because 3 can go into 6 fully. So that's going to have negative 2x cubed. See right here, so boom. This one can't be reduced any further, so I just put it back. Neither can this negative 9x, I put it back, my plus c. And this is not my final answer. My question to you, if you are following me, was that difficult?
Sir, not really.
no, sir.
It's not difficult to know. Mark you, and I'm
Not
going to say this
really,
again.
but we practice.
And I'm going to say this again. You may still not understand it fully just yet, but just follow the procedure because what Sir is going to be doing now is moving on to question 4. So the x to the 0 in green come back here again. In this, let me see if I did jump it right here. So bless the Lord. Bless the Lord. So that very smart student who listens to his teacher to say don't skip a step. Let's go. See the question here now. But sir, why are you not integrating individual terms? Because I don't have to. You see what it is that I want to show you what I'm doing? That is the rule, you know. The rule in question 2 is to factor out the constants. See it here, so in number 3, we factor out the constant. When we reach number 4, now we grow. We stop eat, crush, yaman, banana, and Irish. We can't eat dumpling now because we have teeth. Let's go. Watch me. Please don't blink. Watch what teacher doing. So the question says to integrate 4x cubed plus 3x squared minus x minus 1 dx. Sure. Easy 1, 2, 3. Add 1 to the power, divide by the new power. 4x to the 4 over 4. See this up? 4x to the 4 over 4. Add 1 to the power. 3x cubed over 3. See this up? 3x cubed over 3. Add 1 to the power. Negative x to the first over 1. Rubbishness. This is x to the first power already. So I'm adding 1 to it. So it's going to be negative x squared over 2. Negative x squared over 2. And this -1, because I have x to the 0, it's just going to become -x, right? So plus c. Tell me if you see this answer immediately from doing the question up here. So,
Sir, I have a question.
mhm.
Sir, if like this, we never had to do it like number 3 and number 2. Is it always like that? Like you can just see the answer and without having to like work out all of that long thing,
Can
sir?
somebody answer her for me? The student who say, my teacher says you're supposed to show already. Can you answer Joe for me, please?
Yes, you can.
Tell her again so she can hear, please.
Yes, Joanna, you can.
Okay, yes. That's the point I'm making. I only, Joe, did the question like that because I want to show you what the rules of integration say. Because, you know, there are rules that govern everything. The Bible is our rule book. There are rules that govern everything. So I'm showing you the rules because I don't want nobody to say, but sir, we never did know that. You have the rules. So I'm showing you the applications to the rule. But guess what? These questions on integration, I expect you to integrate and just go ahead and integrate as they are. And once you've integrated, you're good to go. You're good to go. All right? So let's go. So the integration has ended right here. So, you know, the only thing now is that I can fix up. This 4 cancels this 4, so I'm only left with x to the 4th. See it right there, son? This 3 cancels this 3, so I'm only left with x cubed. See it right there, son? There's nothing else I can cancel with the rest of the questions. So I write them back verbatim. Negative x cubed over 2, boom. Negative x, boom. Plus c, boom. Sir, then suppose, oh, you don't have a big C here, sir. Big C, if you see a C, you see. You see, when I integrate everything in one shot like so, I can just write my C so. But when we integrate it different something and put the plus C, plus C, plus C, I'm going to show you some one big C. Because all of the C, them will come together, I will give you one big C. Right? Watch me. No, don't watch me yet. Come, talk to me. And I'm going to call different ones of you. Dan, your turn. And when I call you, please don't let me have to call you 2 times. When I call your name, just unmute for me, please, or else I'm going to be moving ahead. All
Sir,
right?
before you move ahead, if I was to write x raised to the 7th, would it be wrong or
X raised to the 7th? If I slap you, silly boy, your mother go to New City and pray for you. Tariq, what kind of question that, Papa? Remember, this is x to the 4th plus x to the 3rd, you know. The only way you could write x to the 7th is if you're multiplying.
Oh, okay.
I'm going to tell mommy to go to New City and pray for forgiveness that I wonder. Guys, remember this now. The only way you can combine this is unless you are multiplying. But when you're adding, you have to keep them separate. All right, Papa?
Yes, sir.
All right, good. Who made the call a while ago?
Daniel.
Dan, come, Dan, come, quick.
Yes, sir.
All right.
Yes, sir. I'm here.
Okay. When I integrate x to the a, what the rest of is only Dan supposed to answer me. I will ask if he's correct. When I integrate Dan x to the 8th, what do I get?
Okay, so you just want the final version?
Yes, sir.
Okay, so that would be x to the power of 9 over 9.
Is he correct?
Yes, sir.
Yes, sir.
Good job. Dane, you are next. When I integrate x to the 5th, what do I get?
Will it be x to the 6 over 6?
Good job. Sorry, is he correct?
Yes, sir.
Yes, sir.
Good job. Come on. When I integrate negative x squared, what do I get? All right, he's not there. Joanna, when I integrate negative x squared, what do I get?
Sir, negative x third over 3.
Is she correct?
Yes, sir.
Good job. All right, nice. And let me see now. Rajay, are you awake yet? All right, moving on. Tonian, are you awake? Moving on. Chedi, when I integrate negative 5, what do I get? Moving on. Otto, when I integrate -5, what do I get? All right, Otto, not feeling so well tonight, so I shouldn't have caught up on her. Courage, when I integrate -5, what do I get?
-5x.
All right. Is she correct?
Yes, sir.
Yes, sir.
All right. Each of you know your answer. Tell me if that's what it is that you told me.
Sir, I got it correct.
All right. And that's it. So let me ask a question. Is this difficult?
No.
Lotto, is that
Somewhat.
difficult?
No, sir.
All right.
Not anymore.
Not anymore. Bless the Lord. All right. So now that you know how to do that, I want all of you to sit down and take 1 minute to do question number 6 for me. 1 minute to do question 6. Start from it, please.
Sir, finish.
All right, good. Hold that. Kianda, hurry up. Dane, hurry. Dan, hurry. Chedi. You know, understand your call Chedi and Chedi not payment of money. Oh, Jesus, forgive them, Lord.
Here. Sir, I'm here. I'm just zone out for a little bit.
You better zone back in. Rajay, you awake yet? All right. 20 seconds left. Ken. 5. Dan, today's Pick on Me Day. Tell me the answer that you got, Dan.
All right, sir. So that would be 5x. Sorry about that. X to the power of 5 to the 5th power plus x to the 4th power over 4 plus, and this would be x squared plus x plus c.
Is he correct?
Yes, sir.
Yes, sir.
No, he's not.
Can you
He
say the
did.
first one again?
Thank you very much, please, Tariq. At least
Oh,
someone
what
was
did he
listening.
say first?
He just said 5x. He just said 5x to the 5th. He never said over
No, but he
5.
Sir, he
changed it, sir. He's
corrected.
correcting
Sir,
himself. He correct himself.
sir,
He
him
said X.
corrected it
Yes,
and
he's
said
correct
x to the
himself.
5th.
That's why it's correct, sir.
You know, said
Daniel, say
maybe.
it again, please.
No, he correct himself, Terry.
Woman never hears someone. Daniel, say it.
It's all right. Tariq, never mind. We are outnumbered. You were them just rush me. We're outnumbered,
Yes,
Tariq.
sir.
But you see, me I go listen back to the recording, you know. Me I go
You
listen
will.
back to the
Sir, man,
recording.
today say him said, sir, he was
All
going to
right.
say
He said
Okay.
5 to the
X,
x,
and then he
sir,
changed to
and then he
X
changed
to
it to
the
x to the
X to
5th.
5, and then he changed again and said
Okay.
X to the 5th power.
All right, never mind. Dan, one thing I can tell you, you have your back to keep them in the class here. That's all I'm going to tell you, Dan. You must respect them, and your friend them that's in for life. All right,
Yes,
very
sir, I
good.
realize.
Yeah, very good. All right, I'm proud of you, Dan. I'm proud of you. And then no, you recognize no, so boy, it can fix up a little bit because the 5 them can cancel out and the 2 them can cancel out. So if I write this as that, you'd agree with it. It's true or false?
Yes, sir.
Yeah, man, very nice. And we answer question no. Is integration difficult?
Not this part, sir. We had a
All right. I like this. So you know how to integrate now. That's the point. Mark you. There are different types of the integration because I can give you, this is just a basic part of the integration. Once you get the basic part of integration out of the way, you are good to go. When I say good to go, it means that all I will have to do is just build on what it is that you know, and this is why I want you guys to get it. All right. Come on again because I'm not feeling my mind. Joanna, this is yours. The rest of you, I want you to do it too, but Joanna is going to answer me this one. Come, Joe, I give you a minute. The rest of you work it also, you know, and check to see if she is right. And listen to her here because she tell me she says so and she never says so. Oh, she says to nobody answer me. 20 seconds left. 10. 5, 4, 3, 2, 1. What's the answer, Joe?
Sir, x to the 10 over 10 plus 5x to the 8 over 8 plus 3x to the 4 over 2 plus x plus c.
Is she correct?
Yes, sir.
No, she's not. No.
No, she's not.
Okay,
She
The
said,
she
third
said
one,
she
the
said
that. She
third
plus.
said
one need to
plus
fix
She said
5.
it.
plus. She said
Oh,
plus 5.
minus,
No,
minus,
No,
minus.
hold
she
on.
said minus.
No, hold
Sir,
on.
minus.
No, hold on. Remember, mistake, you know. I feel listen to Joy now because she was say, no, sir, I said negative. Me here plus.
Sir,
Anybody
I
here
just
plus with
correct
me?
it and say minus. Sir, I just said
Yeah,
minus.
bugger, yeah.
Yes,
Bugger,
sir.
yeah.
Sir, I just say minus.
Yeah, bugger, yeah. Sir, I listen on for you, but anyway, very good though.
Sir, I just say minus, yes.
Okay, very good. So, and then what she did was she show a formula and never said the 6x to the 4th over 4. She just wants a 3x to the 2. So that's very good. Let me answer the question now. Is this difficult?
No,
Sir,
sir.
no.
Not
Sir, wait
difficult.
until the exam
No,
paper
man.
them come and then you ask.
Remember, I am Bill. I can't ask you about cooking oxtail if I not show you how to cook flash out. When you put the flash out and you eat it and you're not dead, can you cook? Yes. You never ask where you can cook, you know. You ask if you can cook. All right. So if me buy one BMW now, and me buy one 1980 BMW, and say, sir, what kind of drive? BMW. Sir, what brand? What year? Me not answer you. They're driving a BMW. A BMW is a BMW. All right. Good. Let's go. Who one is this one now? This one is going to be Dane. This one is Yearns. The rest of you need to do it. Come, Dane, quickly. 30 seconds, Dane. Start now. The rest of you do it and tell Dane if he's correct. And give another 30 seconds.
Would the answer be
So they don't.
X11?
Go ahead, Poppy. X11.
Would X11 would the answer be X11 over 11 plus X to the 6 over X to the 6 minus 3X over 3 minus 7 plus X plus C?
Is he correct?
No, that no sounds
No.
right, sir.
Sir, that no
sounds
sound
right.
right,
All
you
right.
know.
Okay.
No,
Don't tell him. Don't tell. Don't tell him. Don't tell him. Don't tell him.
That sounds
So,
right.
so the your first term is correct. All right. So then go back and look at it again for sir.
Yes, sir.
No. Don't wait. Don't mute. No, mute. Go Virginia. Go. No man. Start again. X to 11 over 11. Yeah.
Plus X to the 6 over 6
Thank you, please. Good. You left off that for the first one. Continue now.
minus 3X over 3
Why calling this 3x? What number is this?
minus 2X.
2x what?
Nothing. That'd be minus 3.
No. When you see the x up here, sir, what power is this x raised to the n?
1.
So let's go again now, son.
So X. So it'd be 2.
Continue.
So X to the 11th over 11 plus X to the 6 over 6 minus 2X squared minus 7
2x squared what?
over 2 minus
Thank you,
7
son.
plus X plus C.
Minus 7 who then?
Oh, minus 7.
Say x.
X.
Very good. It's not hard, Nadine. Me not
Yes, sir.
ask you. It's not hard. And then, of course, you recognize that the twos can cancel out. So I have a third line. And my third line is going to be that. Let me pause right here. I have 4 minutes. Is there anybody in the class that don't understand what we just did a while ago? I was able to do 8 questions on integration. Is there anybody in the class that don't understand what it is that we're doing or we have done so far? Don't worry about the things to come. If you understand this building block, the foundation, the rest of the stuff will become very easy. I promise you.
Sir, I'm trying to understand. I need to listen because I'm having a headache. But
yeah, man.
But I just saw I'm kind of catching it from the seeing the comparison between the 7 and 8.
All you need to do, and I mean, I don't even want you to open your eyes too much and watch the screen. Hearing what I'm saying is good enough. When you get rid of that headache, I know what headaches are like. I've had a couple of them while I'm teaching, and trust me, it's not pretty. Watch the recording, and then we can talk thereafter. Watch the recording, and then we can talk thereafter. All right, Otto?
Yes, sir.
Good. The rest of you, I want you to ask me. Oh, there's an observation that I'm making. There are 24 of you in my class. And when I just started, I had 13, but of the 13, I'm there twice, so that there are 11 of you. And I got up to 17, which was 15 of you. And then I'm down to 14, which is only 12 of you. You know, I'm just saying, I have no further comments. I'm just saying, this is my observation. All right. I'm not going to do any more. All I'm going to say to you is, let me give you one more for the road. Let's see who first can do this one. Anybody, this is an open question. This one first. When you finish, you can start talking.
So 5x to the 6 over 6 plus 4 plus x to the 5th over 5th plus x. So
So that would be 2x to the 4th. Or
so is it x to the 4th over 2?
Hold on. You pausing us so somebody help you. Come down and finish out.
Sir,
no, you did pausing on somebody pick up, so go on down. You said
so
2x to the 4th over?
X to the 4th over 2.
Right.
Okay, all right.
Then minus x to the 3rd over 3 minus x plus c.
Good job. Good job. When you show up for class, class shows up for you.
So a question.
Yes, Papa.
I did everything right except the x plus c. If I did put 1, I'd get it completely wrong.
If you put 1?
Yeah, instead of x plus c.
Instead of negative x plus c, because a negative.
Yes, instead of negative x, a negative 1.
A question like this may go for about 1. A question like this may be about 3 marks.
Yes, sir.
Yeah. So yeah. So if it's 3 marks, you get 2 out of 3. If it's 4 marks, you get 3 out of 4. So that you'd have lost a mark for that.
Right, sir.
And if you look at the past papers, you will see questions of this nature, of these types that they're asking for 4 marks and 5 marks, right? So it's not too far from what I'm teaching you, right? My final thoughts. Today was a rough day for me. I have been, in parts, thinking about your progress, where you guys are at. what I need to do in order to get you to where you're supposed to be going. And I thought to myself that I have done a revision question on stationary point. Felt really very comfortable with that based on the responses that I was getting from those who were speaking to me. So I know the ones who were having the conversation are really understanding. So I felt really very comfortable moving into integration. I know when I did the rules of integration, some of you had cobwebs building up, especially when I did the first 3 questions, the cobwebs were even there more. It's like, what's that about? And then gradually, as we moved from question to question, it became progressively easier because we were understanding the rules of integration. Now, there are out of the 8 rules, I know one of the rules you know. When you're integrating, you add 1 to the power, you divide by the new power. Talk through. Anybody, somebody?
Yes, sir.
Yes, sir.
And I know you also know that we don't write 1 dx, we just write the integral of dx. And I also know you know that when I'm integrating and I have a negative sign inside here, I can factor out the negative sign. I know you know that when I'm integrating and I have a constant here, I can factor out the constant. A 4 rules no longer you know. I know you know when I'm integrating f of x plus g of x, I can integrate f of x and then I integrate g of x. And if I'm subtracting, I do the same thing. And you know, when I integrate in a constant, it's going to be the constant. It's going to be a constant with that x there. Just like the last one that we talked about, then the integral of -1 here, a constant, is just going to become negative x, which is right here. So on 6, I can remember the other 2 rules that I missed. I did that one, I did 8, I did 7. I spoke about 6. Oh, the exponential one and the logarithmic one, right? So we can talk about those afterwards, right? So far, and it's because I don't do any of the exponential one and the logarithmic one, which is why I missed those 4 and 5. But the others, I give you 8 rules, and based on the questions that we've done in class today, we know how to apply 6 of those rules already. All right? Thank you for coming out. Have yourselves a wonderful rest of the night. Get some sleep. Get up on the
So are you going to send this for us tonight or tomorrow?
I can send this off to you tonight, and as soon as the recording come in. All right. So then you can do what you need to do. All right. We'll talk. All the best. Thanks for coming out.
All right, sir. Good night.
Good night.